Hello, boys and girls. 1.3 solving equations with variables on both sides. There's kind of two sides to this section. There's a solving side, which is pretty much the same as the first two sections in this chapter. And then there's this other stuff, the kind of special equations going on. And so that's sort of the new part, the part we're going to spend a little more time with. And then, the equations are a little more difficult, but nothing too crazy because we're going to stick with our same three steps. Step one, pick sides, and I'm going to add to that a little bit, simplify also. That kind of goes without saying, but I'm going to go ahead and say it. Step two, remove what doesn't belong. So we've got our variable side and our number side, and we get everything squared away, remove what doesn't belong, and get our stuff all situated. And then we're going to multiply or divide depending on the problem. Let's do some real math. Example one, here we go. So I'm going to simplify and pick sides. So simplify, let's see, we'll go ahead and distribute this out. We've got 2x minus 6. And then on the right side, we've got 4x plus 5. And we're going to pick sides. Let's see, I'm going to say my right side should be my x side and my left side should be my number side. Let's do that. I'm going to draw this line too. Keep separated there. Okay, so left side, get my pointer out here. Left side, I want to get rid of, let's see, if this is my number side, I want to get rid of the x's. So get out of here, x's minus 2x and minus 2x. We'll work that out. That's gone. Negative 6 equals 4x minus 2x is 2x and plus 5. Okay, left side's all good there. Right side, this should be my x side. So 2x, you just stay right there, buddy. I'm going to get rid of this 5 here. Minus 5 from both sides. Minus 5, minus 5. Negative 6 and negative 5, we have negative 11 altogether. Careful of those negatives, they will get you. And then we're going to divide, but hold on. 11 can't be divided by 5 or by 2, or can it? We're just going to do this. Look at that. Bam. 11 over 2. That's my answer. So in high school math, that's just what we do. If something doesn't divide evenly, we just make it into a fraction. Move on. We got bigger things to do, right? Come on. If you really want to, you can write negative 6.5, negative 5.5, but I don't know. You just mixed numbers are kind of a little kid thing. I'm gonna say it. I'm sorry you spent so much time going back and forth. When you get to be grown, you use improper fractions. That's just what we do. That's the grown-up world, okay? It's a harsh life out there. Here we go. Example 2. Nothing is simple. Oh, yeah, we got a little bit to simplify here. So 4x plus 5 equals 4x. And we're going to pick our sides. Let's say we'll go x is over here. No, I already got all my numbers there. So I'll go x is here. Oops, I said x's. X's and numbers. Okay, so I need to get rid of these x's over here because this is the number side. So let's go minus 4x and minus 4x. Okay, and that'll be gone there. And I get 5 equals, that'll be gone there. Hold the phone. What is going on? What's this? 5? Well, that'd be 0. 4x minus 4x is 0. What is this? Huh? I have just kind of lulled you into thinking this was a normal problem. It is nothing but normal, kids. This is a very special problem right here. 4x plus 5 equals 4x. Let's just look at that for a second. So you've got some 4 times a number, and then over here you've got 4 times a number. So we know right away this and this are going to be the same thing, right? So how can you have the same thing and then you add 5 to one of them and not the other and it still be the same thing? It can't. That's why the answer to this problem is no solution. If you have a problem like this where you have the same number of variables and then you add or subtract to one side, not the other, Or if you add different numbers to this one, if like that's plus 5 and this was a plus 2, it's going to be no solution, okay? Or like this, if I end up with a untrue statement here, like 5 equals 0, that's impossible. So that's why it's no solution. I'm going to show you a little chart here in a second that will make it all a little more clear. So, because I'm telling you kids, that is not going to be the only weird one we encounter here. 3x minus 10 equals, it's a little foreshadowing for you there, huh? 2 times x is 2x, 2 times negative 5 is negative 10. And let's see, we'll get our x's on the left and numbers on the right. And we are going to, let's see, if this is my x side, I want to get rid of the numbers here. So I'm going to say plus 10 and a plus 10. Do you already kind of see what's going on? See what I'm doing? 3x equals 2x. That's gone. And then if this is my number side, I need to get rid of the x's. Minus 2x. Minus 2x. X equals 2x minus 2x. That's 0. But you know what? That's your answer. X can equal 0. 0 is a number just as good as any other number. Just as good. So it's kind of a special one because you do have the same number of constants. So like on this one, I had negative 10 on the left and I had negative 10 on the right. The one before that, I had the same number of variables. So it kind of fits into that pattern. However, you don't really have to do anything special on these. You just work them out and you have to recognize that 0 is a number. Okay? Example 4. Let's go ahead and work this out. 3 times x is 3x minus 12. By this point in time, you are very cautious. You're thinking there is going to be something funky about this. Now, hold on. Look at this. You notice anything funny about this one? Do you? It is. Yeah, it's the same thing. 3x minus 12, 3x minus 12. Is there an echo in here? It's the same thing. Okay? If you have the same exact thing on both sides, you just stop right there and you say, I know what the answer is. It's all numbers. Okay? Because anything will work. If you think of a number and use it for your x value, so plug in 2. So 3 times 2 is 6 minus 12. Well, that's negative 6. And then plug it in over here. 3 times 2 is 6 minus 12 is negative 6. It's always going to give you the same thing every time because it's the same thing. Same exact thing on both sides. It's going to give you all numbers. There's also this cool little symbol. I didn't show you the cool symbol for no solution. Cool symbol like that. It stands for all real numbers. So there's these things called imaginary numbers, and then we have real numbers. You don't really have to know anything about that quite yet, but right now we just need to know how to make the cool sign. That's all we need to do, okay? And here is your chart that kind of lists everything out. So no solution, that was your cool symbol right there, as promised. And that's when you have the same variables and different numbers. So what I mean by that, the same variables, like I've got the same number of variables, like there's 1x on the left and 1x on the right, and different numbers or different constants. So I have a 3 here and a 5 there. That's going to be no solution because I can't add 2 different things to the same thing and get the same thing. Yeah, that made total sense, right? All numbers. So you get this cool symbol. I think all numbers has the coolest symbol. I don't know. What do you guys think? No solution symbol, all real numbers? So you end up with the same number of variables and the same numbers. They're the exact same. You have 2x plus 1 equals 2x plus 1 or whatever it is. It's the exact same thing. That means all numbers. Now sometimes, like this one we did, you have to simplify it a little bit first and then it becomes the same. But yeah, that counts. That counts. Last one, x equals 0. You have different variables, but the same amount of constants or same number of numbers. So like 2x plus 3 equals 4x plus 3. So on this one, the variables don't really do anything because 3 equals 3 if you just ignore the 2x and the 4x. So that must mean they equal 0. Okay? So we need to know how to do those three types of problems, and then all of our normal ones too. Talk to you guys later. Bye.